everybody and welcome to Pankaj Sir's Echelon Tutorials. And in this today's session we are going to start with a new topic in Igcse, and the name of the topic is Indices. It's a sweet little topic, okay, but of great importance, right? So let me write down over here. This is for Igcse, okay, and this is mathematics, right? And the topic is, as I told you, indices, right? Indices, okay. Sometimes this topic is also referred to as exponents, right? Okay, so indices is the name of the topic. So let us get started, okay. So in this indices, first of all let me tell you what is indices, okay. Indices is any number which is written in the form of a raised to say m, okay. So any number written in this form, for example, suppose you write 2 raised to 5, okay, or you can write 10 raised to 3, okay. Any number raised to another number, this type of numbers are known as indices, right? So a raised to m is a general form of indices. Any indices can be written in form of a raised to m. This a is known as the base and m is known as the power. You can call it power or you can call it index, as you wish, okay. Now the meaning of this is, suppose you write a raised to m, the meaning of this is a you have to take the base and you have to multiply a how many times? M times. So a into a into a into a into dot 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 m times. This is the meaning of this number, okay. For example, if you want to write down 2 raised to 5, okay, this is in the indices form, 2 raised to 5. The actual number will be 2, that is the base. You have to take and multiply how many times? 5 times. So 2 multiplied by 2 multiplied by 2, this is 3 times, this is 4 times, and this is 5 times. 1, 2, 3, 4 and 5. This should work out to 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So the answer is 32. So 2 raised to 5 is same as 32, but it is written as 2 into 2 into 2 5 times, right? So 10 raised to 3 can be written as 10 multiplied by a 10 multiplied by a 10. You have to multiply 10 by 3 times, okay. 10 into 10 into 10. This works out to 1000. So 10 raised to 3 is nothing but 1000. Now there is a algebra. There's an algebra connected to these type of numbers, that is algebra of indices, you can call it, okay. Now for this algebra of indices, you have to understand certain rules. So let me tell you the rules, okay. Rule number 1 is, suppose you have a number of the form a raised to m, and if you multiply this by a raised to n, okay. Remember here the bases are same but the index are different. So a raised to m multiplied by a raised to m will give you a raised to m plus n. Most of the time you will have to use the reverse of this, okay, most of the time, remember. Second law is, suppose you have a raised to m divided by a raised to n. Again here the bases are same, the index are different, and this can be written as a raised to m minus n, okay. Again here the reverse is used most of the time, okay. So don't just remember the formulas in the forward direction, try to remember them in the reverse direction as well. Most of the time you are going to use it in the reverse direction. This is rule number 2. Rule number 3 is, there's something called a raised to m whole raised to n. This will work out to a raised to m into n, that is mn, okay. So these are the 3 laws, okay. Apart from these 3 laws, you have the 4th one, that is a raised to 0 is equal to 1, okay. And the 5th law is a raised to minus m will be equal to 1 upon a raised to m, okay. and the sixth one is anything or a raised to 1 will be equal to a. Okay, so once you understand these 6 laws, or if you understand these 6 rules, okay, you can just apply these rules and work out the numbers, okay, given in the indices form, and you can simplify those numbers. Is that clear? And the seventh one is a raised to m upon n can be written as nth root of a raised to m. Okay? This is the seventh rule. So all these rules, okay, once you are familiar with, okay, you should know how to use them. Okay. So in this indices in the IGCSE level, you have to first understand these rules and you have to understand how to use them. Okay. With this as the reference, okay, let us go to exercise 12 of David Renner book. Okay, and as you know, I am using the David Renner 4th edition, right? So this is exercise number 12, which is on page number 188, okay, of David Renner 4th edition, right? So let us get started. Question number 1 is expressed in the index form. Okay, question number 1 is expressed in the index form. So there are many questions like 1 to 10 to express in the index form. So 1 is 3 into 3 into 3 into 3. Now this is a number which you have to express in the index form. Index form is indices form. So this can be written as 3 raised to 4. Okay, because you have multiplied 3 4 times. Second one is 4 into 4 into 5 into 5 into a 5. Now this can be written as 4 is multiplied 2 times, so you can write 4 raised to 2, and 5 is multiplied 3 times, so you can write into 5 raised to 3. Okay, so this is the index form. The third one is 3 into 7 into 7 into 7. Now this is 3 is just a single number, so you can write 3 only, or you can write 3 raised to 1, and into 7 raised to 3, because 7 is multiplied 3 times. Fourth one is 2 into 2 into 2 into 7. This can be written as 2 raised to 3 into 7 raised to 1. If you don't write this one also, it doesn't make any difference. Okay. Fifth is 1 upon 10 into 10 into 10. This can be written as 1 upon 10 raised to 3, which can be again written as 10 raised to minus 3. Now this is that rule. Which rule I was talking about? I mentioned that rule over here. A raised to m can be written as 1 upon a raised to minus m, or a raised to minus m can be written as 1 upon a raised to m. Okay, both are having the same meaning, right? Okay. So according to that, 1 upon 10 raised to 3. See, the indices form in the denominator, when you take it in the numerator, the index ka sign changes. So 3 ka sign will change from plus to minus. Okay, that's how it works. The sixth question is 1 upon 2 times 2 times 3 times 3 times 3. Okay, this can be written as 1 upon 2 raised to 2, because 2 is multiplied 2 times and 3 is multiplied 3 times, to 3 raised to 3. Now this can be written as 2 raised to 2 is in the denominator, so take it in the numerator, it will become 2 raised to minus 2. And again this 3 raised to 3, if you take it in the numerator, it will become 3 raised to minus 2. So this way also you can write. Okay. Seventh. The seventh one is root of 15. Now root of 15, if you want to write, you can write it as 15 raised to 1 by 2. Okay. See, square root, you know, means you have a 2 over here and you have a 1 over here. Okay. Here what rule I have used, you know, the seventh one, a raised to m upon n is equal to nth root of a raised to m, isn't it? This I have used. Okay. So here, see, I have used in the reverse way. Okay. See, root of 15 means you have a 1 over here and you have a 2 over here. So this can be written as 15 raised to this 1 upon 2, isn't it? So that is how I have written this, 15 raised to 1 upon 2. Then 8th one is it's a cube root of 3. So this can be written as this 3 you have to write first. Then there's a 1 over here, so write on 1 divided by this 3. So 3 raised to 1 by 3. Okay. Again, this has been used over here. Okay, see carefully, you'll get it. Okay. Then the 9th one is 5th root of 10. This 5th root of 10. So this can be written as 10 raised to 1, right? So this can be written as 10 raised to 1 divided by this 5. 10 raised to 1 by 5. Okay. Again, the same rule has been used. Then the 10th question is square root of 5 whole raised to 3. Now this can be written as, first you do what? Square root of 5 you write as 5 raised to 1 by 2. Then you put this bracket and write this 3. Then you use that law, a raised to m whole raised to n is equal to a raised to mn. Using this law, what you will get is here 5 raised to 1 by 2 into 3, that is 3 by 2. So this is your answer. Is that clear? So first 10 questions of this exercise 12 we are done with. Okay. Now let us move on to question number 11, and these questions from question number 11 onwards are simplified. Simplify means you have to just make them as simple as possible. So this is question number 11. It says that x raised to 3 into x raised to 4. Now see, now we are not dealing with pure numbers, okay? We have a variable and you have a power as a number. So x raised to 3, x raised to 4. But because these bases are same, we can use the law and we can write this as x raised to 3 plus 4, which is equal to x raised to 7. Is that clear? Here which law I have used? A raised to m into a raised to n is equal to a raised to m plus n. Okay? But the condition is the base should be same. Okay? And here the bases are both same, x. And that is why we made it x raised to 3 plus 4, that is x raised to 7. Question number 12 is y raised to 6 times y raised to 7. Again, because the bases are same, you can write y raised to 6 plus 7, which is nothing but y raised to 13. Okay. Next one, 13. It is saying that z raised to 7 divided by z raised to 3. Okay, so this is division. Okay, so you will have to do subtraction, and because the bases are same for both, so z raised to 7 minus a 3, that is nothing but z raised to 4, right? That was 13th. 14th is z raised to 50 into again a z raised to 50. Z raised to 50 multiplied by z raised to a 50. Now because the bases are same, z, so you can write z as common, and 50 plus 50, so this is working out to z raised to 100, right? Next, 15th, it is m raised to 3 divided by m raised to 2. Now because it is division, it will be m raised to 3 minus 2, that is m raised to 1. So this you can write just as m. You can ignore this 1. 16th is e raised to minus 3 multiplied by e raised to minus 2. So this will be, the bases are same, so it will be e, and this will be minus 3 plus a minus 2. So that will be minus 2. So this will work out to e raised to minus 3 minus 2 is minus 5. So you can write the answer as e raised to minus 5, or you can also write it this as e raised to 1 upon e raised to 5. This negative 5, if you bring this indices form number in the denominator, then the sign of the index will change from negative to positive. Okay, so e raised to minus 5 can be written as 1 upon e raised to 5. Okay, so see, what I am doing here is I am applying all the laws, all the rules that we have mentioned in those 7 points. Okay, that only I am using over here. 17th one is y raised to minus 2 multiplied by y raised to 4. So this will be equal to y raised to minus 2 plus a 4. This will be y raised to 2. Okay, minus 2 plus 4 is 2. Okay. Find 18th. 18th one is w raised to 4 divided by a w raised to minus 2. Okay. So this will work out to w raised to 4 minus minus 2. Okay. Which will work out to w raised to 4 plus 2, which is equal to w raised to 6. Okay. The 19th one is y raised to 1 by 2, okay, into another y raised to 1 by 2. This can be written as, because the bases are same over here, you take base as y and the index is half and half, so you add those half and half. 1 by 2 plus 1 by 2. This should give you y raised to 1 by 2 plus 1 by 2, that is half plus half is 1. You can write y raised to 1 or you can just write y. Okay. And the 20th one will be x raised to 2 whole raised to 5. Okay. Now here you are going to use that law, a raised to m whole raised to n is equal to a raised to m into n. So here it will be x raised to 2 into 5, that is 10. That's the answer. So we have solved some 20 examples, 20 questions from this exercise 12, and there are many more to go. So one by one we'll do these questions, okay, in the subsequent videos. For today, that's all. See you next time in the next video in the continuation of this, and till then, goodbye. Take care all of you.